So this is the second part to applying systems of equations. So we are on number 3. At a clothing store, t-shirts cost $10 and sweatpants cost $15. If Autumn spends $220 after buying 16 items, how many did she buy of each? So in order to determine our variable, we need to look at that question. How many did she buy of each? Well, what is each?
T-shirt and sweatpants.
T-shirt and sweatpants. So we are going to use the variable t and the variable s. And we don't have to do both substitution and elimination. We get to decide what method to use. So we are going to set up 2 equations, one that deals with quantity, because we realize that there are 16 items, so that's quantity, and one that deals with the value, which is 220. And then we assign the variables to be represented in this equation. So the quantity, we know that t-shirts and sweatpants are going to add up to equal 16. And then we know the cost of each. So $10 per t-shirt plus $15 per pair of sweatpants. Looks like $155, but that's an S. I'm going to make it look like an S like that. So we can use any method we choose on this. Because they're both in standard form, I would say elimination or matrix. So I'm just going to do the matrix. That'd be 1, 1, 16, and 10, 15, and 220. Second matrix, RREF, alpha zoom, a 2 by 3, 1, 1, 16, 10, 15, and 220. Whenever we do that, we get 1, 0, 4, 0, 1, 12. And so from that, it tells us what our variables are equal to. So I've had this question by several people. How do you know which one's T, which one's S? So you look and see, what did I originally have? I had T and S. So this is going to be T, this is going to be S. And if I transfer it back to standard form, I would get 1T plus 0S equals 4. And if we simplify that, that's just T equals 4. So the first row, if it has a 1, that goes with the number. Second row, if this column has a 1, then it equals that number. So it's like saying 0T plus 1S equals 12. Just means S equals 12. So now we can write our answer in words. So we'll look back up at the situation. She spends $220 after buying 16 items. How many did she buy? Let's just make sure. 4 and 12, that makes 16. And then if I multiply 4 times 10, 40. 15 times 12, I don't know that in my head. 180. So 180 plus the 40 gives 220. So that means we did it right. So we have Autumn buys 4 t-shirts and 12 sweatpants. So if it's a word problem, make sure to write your solution in words, in a sentence. Let's look at number 4. We're not going to solve this one. I just want you to read it and then you'll do it on your own. At a bake sale, cookies cost 25 cents and brownies cost 35 cents. If Nathan spent $3.15 and bought 11 treats, how many did he buy of each? So something that a lot of people are missing is this, 11 treats. So that's what it's getting people.
Kind of looks like 2 rounds.
I know it does.
Bad pot.
Okay, let's go to number 5 now. So you'll do number 4 on your own after you finish 5. A medium pie at Olivia's Pizza Shop costs $6.80 plus 90 cents per topping. A medium pie at Nathan's Pizza Shop costs $7.30 plus 65 cents per topping. So we have the 2 pizza shops, Olivia's and Nathan's. So I'm going to write Olivia's over here and Nathan's over here. So this says $6.80. So it costs $6.80, but then we have 90 cents per topping. So what is our variable going to be? T for topping. But let's use X instead. So I'm going to put T toppings equals X. And then we're talking about cost. This doesn't have a question, so I'm going to add a question. What or which shop is more affordable? So when we're talking about Olivia's, we have $6.80 plus 90 cents per topping. So our X is going to be with the 90 cents. So we're going to write it as a Y equals MX plus B equation. So it's Y equals, it's 90 cents per topping, so that'll be 90 cents times X plus the $6.80. And then Nathan's is going to be, the per topping is your X, so 65 cents times X plus $7.30. We're going to graph this to find our solution because they're both written in Y equals. We're not going to graph it on here because we have these decimals going on. Let's just focus on using the calculator this time. Okay. So let's go to Y equals. Put these 2 equations in. And go to graph and make it do just quadrant 1 because we're only dealing with positive. So that was back at zoom quadrant 1. Okay, so you can see your 2 lines. So let's find out where they intersect. So second trace, 5, Enter. So let's talk about what 2A.6 even means. What'd you say? That's where it's even, the same. So the pizzas cost the same with 2 toppings. And that cost is $8.60. So now we just need to decide which one's more affordable. So does it kind of depend on how many toppings you're going to get? If I'm ordering a pizza for Olivia, for my daughter, she's going to want cheese pizza. But if it's for me and Mystery Saucy, we are going to want beef, bell pepper, onion, mushroom. So it'll be more affordable to go with this one. But for Olivia, we're not adding extra toppings, so that's only $6.80. So let's talk about what should we write here as our solution.
Olivia's is better for less than 2 toppings. Less toppings and Nathan's is good. Olivia's is better for 1 and 9, and Nathan's is better for 2 more. I don't know.
Yeah, that's exactly right. More affordable for 1 or less toppings.
Negative toppings.
0 or 1, right?
Pizza with 1 beef.
Yeah. And then Nathan's is more affordable for toppings for 3 or more toppings because they're the exact same at 2. I'd say 3 or you can put 2 or more, but just remember 2 is where they're the exact same. Yeah, that would be if you're ordering 2 toppings. Really, it doesn't matter which one you're going to go to. Okay, so you are going to finish number 6 and number 4 by yourself. Shout out to 5th period. Y'all are a great group of kids. Anyone specific?